Okay, today we're going to start chapter 2.2. Basically, this is mathematical expectation. Mathematical expectation actually has no basic definition, but we can give some example. Okay,
Okay, sir.
like I want to show. Can you see the board?
Yes, sir.
Yes, sir.
Let you have 3 trees. How many trees?
3.
3 trees. Say T1, T2, T3. They are the trees. Probability of that selection is probability of T1, probability of T2, probability of T3. Say they're the mango trees, and this mango tree you can sell. You can sell the mango from this tree is taka x1, then x2, then x3. Now I can ask you how much money you can expect. What can I ask? How much money
How much money?
you can expect? Now, for the first tree, you can earn x1, but its probability is p of t1, but this is not rigid. Or you can earn x2, and probability of earning is p of t2. Then you can earn x3, and probability of this earning is what? P of t3. This is your expected earning. This is what?
Expected earning.
Expected earning, and this is called the mathematical expectation. We denote this by expectation of x. Denote by what?
Expectation of X.
Expectation of x. Now one thing here, we have given input x1, x2, x3 directly. Say some product actually not available in the market, so definitely its price will be high, right?
Yes, sir.
And say your probability remains same, but now the price is uh, say defined by, say let us say defined by twice x. That is, the price is increased by 2 times. How many times?
2 times.
So your input will be changed, whereas probability remains same. Okay. So this is also the expectation, but now definitely the expectation will be high. This is because of the scarcity of the product. When there is no supply of rice, the price of the rice going high. So you have to buy a sack of rice, at least minimum 500 taka more, isn't it? দাম বেড়ে যায় না?
Yes, sir.
এটাই সেটা, দাম কিভাবে বেড়ে যায়। Even sometimes it's very say the vaccine, corona vaccine is totally not in our hand. So sometimes people maybe agree to give squared value of the money. তারা বর্গাকারে টাকা দিতেও রাজি, তাও ভ্যাকসিন চাইতে পারে না।
জি স্যার।
Then the cost for the vaccine will like this. You can see the probability is not changing, right? Only what is changing?
Price.
Price is changing. And actually the new prices are the function of the original price, right?
Yes, sir.
So in general we can write expectation of ux is a function of x. It may be x, it may x squared, it may x cubed, it may anything, which is sum of ux px or pt1. If not, I am not taking the tree, I get directly x from here, then we should write this ux fx, where fx is the PMF. Fx is what? Probability mass function. Fx is what?
So PMF, probability mass function.
Mass function. So this is the mathematical expectation. That is how expected value you can desire. Not only expected value, expected cost, expected price, expected gain, everything. What can be under the economics? What is this? Under the courses of economics. Anything. Okay? Is it clear? Then I am going to the book. Okay. Say a enterprising young man who needs a little extra money devises a game of chance, like some game to income extra money. The game that he progresses is to let the participant cast a fair die. So for a fair die, how many outcomes? Asif, how many outcomes?
So
6 outcomes.
6 outcomes.
6 outcomes. They have said if the participant can take a found 1, 2, or 3, he will get $1. What he can win?
So $1.
$1. If he can find 4 or 5, he will get $2. And if he can find a 6, he will receive how many dollars?
$3.
$3. So the price is in our hand: $1, $2, $3. And now we need the probabilities. What do we need? Probabilities. What?
Probabilities.
You can see out of 6 outcomes in A, there are 3 outcomes. So what is the probability of A?
3.
3 by
No,
Oh,
3
yeah.
by 6.
3 by 6.
Similarly, tell me what is the probability of B?
2 by 6.
2 by 6. What is the probability of C?
1 by 6.
1 by 6.
Then using probability and the dollar rate, the prices, you can find the expected income. That is, say, $1 with the probability 3 by 6, $2 with the probability 2 by 6, $3 with the probability 1 by 6. It will be 3, 4, 3, 10 by 6, so 5 by 3. So the player can expect he can win 5 by $3. Do you understand?
Yes, sir.
Okay. Sometimes the probabilities are not given, but the PMF will be given. Like the probabilities are decreasing over the time. Am I right?
Yes, sir.
So according to chapter 2.1, we can write this fx equal to this. That's what we have said. Do you understand?
Yes, sir.
Let's go back. Sometimes we can, what I have shown you, like y equal to x square. That is, now we are not importing x. We are importing what? X square. If we import x square, y equal to x square, so x equal to root y. Am I right? Okay.
Yes, sir.
Then you can see we have fx equal to 4 minus x by 6. It will be 4 minus root y by 6. You can see. In this case, the probabilities remain same. I have said as like probabilities remain same. You can put since x equal to y equal to x square, you can get y equal to, if x equal to 1, y equal to 1, x equal to 2, y equal to 4, x equal to 3, y equal to 9. Am I right?
Yes, sir.
So y is actually, this is the input and this is a variable. If you declare the variable, it will be capital letter. If you give the input, it will be small letter. So the variable is changing, probabilities remain same, but you can see expectation changed because we have defined the requirement in a new process. We have defined in a what? New process. That is, now the output is squared of the original input. What I have said?
Square of the original input.
Square of the original input. Okay, that's why probability remains same, but the expectation changing. This is what I have said. So this is expectation. Now another example we can consider. Sometimes we don't redefine the function, but we rename the function. ওখানে আমরা redefine করেছি, right? But sometimes we don't redefine, but we rename, নাম দেই, define করি না, তখন কিন্তু probability চেঞ্জ হলে হইতে পারে, কিন্তু তার কি হবে না, expectation চেঞ্জ হবে না, কি হবে না,
Expectation change হবে না।
চেঞ্জ হবে না স্যার,
expectation change হবে না. That is an example of what you can see. Try to understand. Fx is 1 by 3. Actually, we know 1 by m, where x equal to 1, 2. This is uniform distribution. Can you remember? Anyway, leave it, because this is not 1 to n, this is minus 1 to 0, so this is not a uniform distribution. Here fx is 1 by 3 and the input set is minus 1, 0, 1. What is the input set?
Minus 1, 0, 1.
Okay, they asked to find the expectation for x square. Already at the initial position, they asked to find the probability of x square. Sorry, expectation of x square. So expectation of x square is equal to x square fx, so minus 1 whole square 1 by 3, 0 square 1 by 3, 1 square 1 by 3. What is the result?
2 by 3.
So expected outcome for the x square or gain is 2 by 3. Let us rename. Here ux is said x square. Now we are taking ux equal to y. Actually not defined newly, just we haven't defined, we have renamed. Define করি না, কি করেছি? rename করেছি, ux কে y ধরে নিয়েছি. Now if we take equal to x square, so if x equal to minus 1, y equal to 1, if x equal to 0, y equal to 0, again if x equal to 1, y equal to 1. So only how many values here now? How many inputs?
2 inputs.
2. Because minus 1 now assigned to what? 1. Minus 1 এর সাথে এখানে ঢুকে গেছে, তাই না? যেহেতু x square minus 1 and 1 দুটো কি হবে? 1 দিবে না y তে?
Yes, sir.
Now we have to rewrite the probabilities. Y equal to 0 actually connected to x equal to 0, which is probability 1 by 3. But y equal to 1 is connected to x equal to minus 1, also x equal to 1. So both of the probabilities will be added. So what is the probability of y equal to 1?
2 by 3.
2 by 3. Be careful, because total probability must be 1. Here all the probability 1 by 3 plus 1 by 3 plus 1 by 3 is equal to 1. Also 1 by 3 plus 2 by 3 is 1. Total probability must be
1.
Otherwise you are wrong. Now find the probabilities. 0 into 1 by 3, 1 into 2 by 3. What is the probability? 2 by 3. And you can see exactly this, right? So there is no problem at all. Clear?
Yes.
Now let's go to the next math. The mathematical expectation satisfies the linearity condition. What is the linearity condition? Constant of any expectation, expression of the constant is constant itself. That is, if you take the expectation of 4, it will be 4. There is no change. Okay. Then expectation of the constant of any function is constant of this. Like if we write expectation of 4x squared, it will 4 expectation of x squared. Do you understand?
Yes, sir.
And their combination actually this. That is, if you write say 2x minus 3x squared, it will be 2 expectation of x minus 3 expectation of x squared. That is, you can calculate them separately and then input there. But it is not necessary to find this directly. You can individually find them and then put here. Do you understand?
Yes, sir.
Okay. Now we use it. Here fx is taken by x by 10, where x equal to 1, 2, 3, and 4. And now sometimes expectation of x is written as mu. Mu means the mean or average. Mean or
Average, sir.
average. This is mean, mu. So the expectation is 1 to 4, here 1 to 4, x fx. 1 into its probability, 2 into its probability, 3 into its probability, plus 4 into its probability, which is 3. Similarly, expectation of x squared is x squared fx. So x squared into its 1 square into its probability, similarly up to the 4 square plus its probability is equal to 10. Now, what can we write? Here, you can write 5x minus, if you multiply this, 5x minus x squared. So 5 expectation of x minus expectation of x squared. Just put the value, you'll get the desired result. You understand?
Yes, sir.
Yes, sir.
4 is not necessary, 4 is theory. That is, if you consider x minus b whole square, it will give you the minimum expectation if b is the expectation itself. ঠিক আছে, এই ফাংশনটা তোমাকে মিনিমাম এক্সপেক্টেশন দিবে যদি বিটা কি হয়, এক্সপেক্টেশন হয়। এটা থিওরি, এটা মুখস্থ করার দরকার নেই, শুধু এই যে বুঝলেই হলো, এটারও দরকার না আমাদের, এগুলো সব থিওরি। আমরা এটা দেখি নাম্বার 6। Before going to take number 6, I want to take one thing. Say your mother sent you to buy the sugar. What you have to do? Buy sugar. Now, if in the first shop sugar is not available, what you will do?
I'll go to the second shop.
Right. If second shop missing, you'll get third, go to third, then fourth. Say you got the sugar at the 5th shop, then you must come back to the home. Am I right?
Yes, sir.
That is, you get the success at 5th time. Sorry, you got the success. You got the success at 5th time. Now tell me, how many times you failed?
4 times.
Very good. You failed 4th times. That is the case. That is, a person has the probability of success is p, when p between 0 to 1, and probability of failure is 1 minus p, that is q, because success and failure are the complements. Am I right?
Yes, sir.
Since they are complement, we can write p plus q equal to 1, right? So probability of success and the sum of the probability of success and failure is 1. Now say you got the success in xth trial, so definitely you failed in up to x minus 1 trial, right?
Yes, sir.
So you failed up, then you failed up to how many times?
X minus 1.
Then you got a success. So product of the q x minus 1 time will be q to the power x minus 1 p. This sort of distribution is called, this is a distribution discrete distribution because you are finding the probabilities of getting success. You are finding the probability of getting success. You have infinite trials, infinite time of trials, but you have to get the success for once. This is called geometric distribution. This is called what?
Geometric distribution.
Geometric distribution. But you know, if there is a distribution function is given, that is PMF is given, total sum must be 1. Total sum must be what?
1.
1. This is valid for here also. So we have to check whether the total is 1. Let's go. Here the total P is 1, only one P. Now put x equal to 1, you get q to the power 0 equal to 1, then q square up to q cube. Then this is infinite geometric series, and we know the infinite geometric series actually what? Its first term is 1 divided by 1 minus the ratio is q, right?
Yes.
Where q less than 1. So p into 1 minus q. But we know 1 minus q equal to p. So p by p equal to 1. So total is 1. That is, the assumption we have made, it's correct, right?
Yes.
So this is only a way to show the obtained function is a PMF. Okay, let's go to the, now we have to find the expectation, that is expectation of x for the geometric distribution, that is expected trial, মানে কতবার তুমি চেষ্টা করতে হবে মিনিমাম তোমাকে সাকসেস পাইতে হইলে, মিনিমাম কয়বার চেষ্টা করতে হবে, বুঝতে পারছো? এভারেজ ট্রায়াল, দ্যাট ইজ এভারেজ কতবার চেষ্টা করলে তুমি সাকসেস পেতে পারো, লাইক আনুমানিক কত দোকানে সার্চ করলে তুমি চিনি কিনতে পারো, এটাই হচ্ছে এক্সপ্রেশন অফ এক্স। ডু ইউ আন্ডারস্টুড?
Yes, sir.
So x of x, x equal to 1 to infinity. If you put 1, x equal to 1, 2, 3, here put x equal to 1, then p, because q to the power 0 equal to 1, then qp, 2qp, 3q square p. Actually you cannot solve this because we have no such kind of series. আমাদের কোনো স্ট্যান্ডার্ড সিরিজ আমাদের হাতে নাই, তার মানে এটা আমরা সরাসরি ক্যালকুলেট করতে পারবো না, রাইট?
Yes.
We need some help from any other function. This is one kind of technical cramming because হঠাৎ করে তুমি এটা মনে করতে পারবে না, তোমাকে এটা মনে রাখতেই হবে এভাবে। Just multiply q with mu, we'll get qp, 2q square p, 3q cube p. Now if we divide mu minus q mu, what will happen? 1 minus q mu, am I right? Okay.
Yes.
This is equation 1, equation 2. So we are doing 1 minus 2. That is, this is, so 1 minus 2. So qp, sorry, not 1, right, 1 minus 2. P, then 2qp minus qp, 1qp. 3q square p minus 2q square p is equal to q square, qp, q square. Similar to this. তার মানে প্রতিবার একটা করে থাকবে, বাকিগুলো কি হয়ে যাবে? ক্যান্সেল হয়ে যাবে। কি হয়ে যাবে? Cancel হয়ে যাবে। Then if we take p as a common factor, this is once again an infinite geometric series. So p into 1 by 1 minus q. So 1 minus q equal to p, p by p equal to 1. So 1 minus q mu equal to 1. So mu equal to 1 by 1 minus q. That is 1 by p. So we have to try 1 by p times. How many times we have to try?
1 by p times.
Now I want to relate this to the real life. Like, say you have 50% success rate. How much percentage you have the success rate?
50%.
That is 0.5 in probability. So if we put 1 by p 0.5, we have to try 2 times, right? It's logical, right? কারণ 50-50 চান্স হলে তো দুইবার ট্রাই করতেই হবে, করতে হবে না?
Yes, sir.
If we have for 25% accuracy, that is we have to try 4 times. 25% accuracy থাকলে 4 বার ট্রাই করতে হবে না?
Yes, sir.
That is the case. Do you understand? But in your exam, you haven't to verify, actually derive this. You have to just use. তোমার এটা তোমাকে derive করতে হবে না, তুমি জাস্ট এটা ইউজ করলেই হবে। বুঝতে পেরেছো? ইটস দ্য বটম লাইন। আমার পরীক্ষায় ডেরিভেশন গুলো দেই না। ওকে, now exercise 2, 3, 4, 7, 11 and 12. They are in our syllabus. Okay, do you understand?
Yes, sir.
Yeah,
11, 12 for combination, sir.
2, 3, 4, 7, 11, 12. 2, 3, 4, 7, 11, 12. Okay, now I want to say one thing. In probabilistic model, there are two types of events, basically according to their sequence. Some events are scattered. You can take anyone from those outcomes at any time. Like you have 4 marbles in the floor. You can take anyone. Am I right?
Yes, sir.
This is scattered. But say you are traveling from UIU to Gazipur. You must first cross the Notun Bazar, then the Uttara, then Gazipur. Am I right?
Yes, sir.
You cannot scatteredly go to the Gazipur directly, or you cannot go Uttara directly without passing through the what? Notun Bazar. So they are the sequential. They are not scattered. They are
Scattered.
sequential.
Mention, sir.
Sequential. Like you are traveling through an elevator. You must to go first floor, then the second floor, then the third floor, and then the fourth floor continuously. Am I right?
Yes, sir.
You cannot escape. This is the sequential events, the sequential outcomes. In this chapter, we'll get both of them. Okay, here too, let x are the random variable x with the PM of this. Inputs are these. Find those. So I'm going to the lecture sheet directly. Just follow me. As you're talking stuff on me, I'm doing the math. If you have any problem, please ask me. Do you understand? Do you understand it? Hello.
Yes, sir.
Any problem?
No, sir.
That is, you have to first find the probabilities. Then using the probabilities and input, you have to find expectation. It may x square, it may x, it may twice x, or so more. But it's given. But sometimes some more outcomes can be found for this. That is the result. Now 3. 3 is the math. What I have said, sequential. Let the random variable x with the number of days in a certain patients need to be in hospital. Suppose the PMF is this, where x is 1, 2, 3, 4. That is, the patient actually staying at the hospital how many days? 4 days. How many days?
4 days.
4 days. It says that if the patient receives $200 from the insurance company each for the first 2 days. First 2 days he will receive $200 for each, and the next 2 days $100 for each, which is the expected payment. Now, one thing I have to say, in the first day he will get $200, and definitely the company will not take away this dollars. So in the second day he will get 200 plus 200. How many dollars?
$400.
400. Because the insurance company not actually taking back the money. Then in the third day, 400 plus 100, they will have 500, and in the last day he will get another $100. So in total, how much dollar he can earn? 600. Okay. Do you understand it?
Yes, sir.
Now you can see, if you put x equal to 1, you will get 4 by 10. For 2, you will get 3 by 10. Then for 3, you will get 2 by 10. Then 4, you will get 1 by 10. So we have the probabilities P of x equal to 1 is 4 by 10. P of x equal to 2 is 3 by 10. P of x equal to 3, 2 by 10. P of x equal to 4, 1 by 10. Then now we can find the expected payment. Say expected payment. First day 200 with priority 4 by 10, 400, 3 by 10 plus 500, 2 by 10, 600, 1 by 10. So this is $360. So the patient can expect how much dollars?
$360.
$360 for the hospitalization. Now, number 4. This is about the insurance. And now you will say the cruelty of the insurance company. So read the question number 4 carefully. And tell me what we have to do.
Deductible 1 unit, 1 unit, 2 units.
That is, an insurance company sells automobile policy which is deducible by 1 unit. That is always the company will take away 1 unit of your payment. তারা অবশ্যই তোমার একটা ইউনিট ধরে রাখবে, ওটা তোমাকে কখনো কি করবে না, করবে না। ওটা এরকম, মানে এটা পলিসির ভিতরে আছে কিন্তু আমাকে বলে না, বুঝছো? এমনভাবে সেট আপ করে, এমনভাবে সেট আপ করে তুমি অবশ্যই একটা পার্ট পাবা না। ব্যাপারটা খুব মজার। সেটা হচ্ছে তুমি দেখবা যে তুমি তো পেয়ে গেছো সব, আরেকজন থেকে আরেকজন অনেক কম পাবে, তো আলটিমেটলি এভারেজ করলে কি হবে, একটা পার্ট তাদের কাছে থেকেই যাবে। বুঝতে পারছো? ওকে, now it says that let x have the amount 0.9 x equal to 0 মানে 90% ক্ষেত্রে কি তাদের কিছুই দিতে হয় না, 90% ক্ষেত্রে কি হয়, দিতে হয় না। তাহলে দেখো 90% ক্ষেত্রে ইন্স্যুরেন্স কোম্পানি লাভবান হয়। বুঝতে পেরেছো? Hence, for x equal to 1, 2, 3, 4, 5, 6, they have to give you c by x amount of probability of this. They will give you this dollars, but that is unit. This unit 6, well, 1 unit, 2 unit, 3 unit, 4 unit, 5 unit, 6 unit. Where are 6 unit? Now, what is the constant c? First, we have to find the constant c, and then we will find the expected value of the amount that insurance company must pay. You understand? So let's go. This is 4. Now we know they are given fx is equal to 0.9 for x equal to 0, c by x for x equal to 1, 2, 3, 4, 5, and 6. What we know? We know the total sum is 1, right? Then 0.9 plus, we can take c in as a common, c 1 by x, so 1 plus half plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 equal to 1. Now after the solution, we will get c equal to 2 by 49. Also, you can write in the decimal form. Okay, I will accept if you write in the decimal form. No, so don't be hesitated. Okay,
Yes, sir.
now come back. So we have to write fx in the newer form. So fx is now 0.9 and x equal to 0, 2 by 49x for x equal to 1, 2, 3, 4, 5, and 6. Now expected value. We have the expected value x, expectation of ux. Actually, there is a new function. We said reducible by 1, that is x minus 1 f x. Am I right? Okay. Now, in the first part, there is no x involved. So in this part, deduction cannot be made. So here 0 and its probability is 0.9. 0 and its probability what? 0.9. 2 by 49 is a common factor. Then reducible by 1. So first term actually 0. X is now 0 into its probability 1 by x, that is 1. Then for 2 you will get 1 into its probability, that is for each you have to use 1 less, half, plus 2 into 1 by 3 plus 3 into 1 by 4. You can see probability remains same, but the values are decreasing. Am I right?
Yes, sir.
And after the calculation you will get 71 by 490. You can see the expected value. You can see 71 by 490. Can you use a calculator? Anyone?
Zero 0.144.
Very unfortunate. You can see this is not 0.25 though. 25% পর্যন্ত তোমাকে ফেরত দিচ্ছে না, তোমাকে সর্বোচ্চ কত ফেরত দিচ্ছে? 14.4%। অর্থাৎ সবার থেকে যে নেয় অনলি 14.4% তারা ব্যাক করতে হয়, বাকিদের কি করতে হয় না?
ব্যাক করতে হবে।
তাহলে ইন্স্যুরেন্স কোম্পানির পরিস্থিতি বুঝতে পারছো?
Yes, sir.
মানে তারা তোমাকে বুঝাই ছাড়বে আপনি মরে গেলে আপনার লাভ, বেঁচে থেকে কি করবেন? ঠিক আছে, মরে গেলে অনেক টাকা পয়সা পাবেন, ওটা কে পাবে সেটা আর বলে না, তাই না?
Yes, sir.
এই হচ্ছে অবস্থা। Now we're going to a casino. Casino number 7. In a gambling game, chuck a luck for $1 bet. That is, you are importing $1. It is possible to win $1, $2, $3, but $1 probability 75 by 216, $2 probability 15 by 216, and $3 probability was what? 1 by 216. That is, if out of every 216 only one get $3, মানে 216 জনের মধ্যে মাত্র একজন $3 পাবে, তাহলে অবস্থাটা বুঝতে পারতেছো?
Yes, sir.
And $1 lost is probability this, যার মধ্যে 216 জনের মধ্যে 125 জন ওটা হেরেই যাবে, অর্ধেকের বেশি হেরে যাচ্ছে না?
Yes, sir.
216 জন অর্ধেক 108, আচ্ছা অনেক বেশি হেরে যাচ্ছে, তারপর মানুষ লোভে পড়ে, মনে করে আমি যদি 216 জনের মধ্যে একজন হই, এই লোভে খেলতে নামে, তারা বেশি ভাগে হারায়। তাহলে এখন বলতেছে তাহলে এটা হলে ফাইন্ড দ্য এক্সপেক্টেড ইনকাম, দ্যাট ইজ পে অফ, কত পেতে পারে। নাও ইফ ইউ গেট ইট উইল পজিটিভ, ইফ ইউ লস ইট উইল নেগেটিভ। পাইলে যোগ আর না পাইলে হারাইলে বিয়োগ। সো শর্টকাটে করে দিই। সো দ্য এক্সপেক্টেড পে অফ, you can earn $1 with probability 75 by 216. You can earn $2 with the probability 15 by 216. You can earn $3 with the probability 1 by 216, and you can lose $1 with probability 125 by 216. After calculation you will get -17 by 16. মানে সবাইকে যদি সবকিছু দিয়েও দেয় শেষ পর্যন্ত এই পরিমাণ মানুষের লস থাকে, মানে যারা বোর্ড চালাচ্ছে তারা এই পরিমাণ অর্থ নিয়ে বাসে চলে যাবে, সবাইকে যদি সব দিয়েও দেয়, মানে সবাই খুশি যে আমি জিতছি, তারপর তাদের কাছে কতটুকু থেকে যাবে? 17 by 216, এই জন্য $1 থেকে যাচ্ছে, লাখ লাখ ডলার ইনভেস্ট হয়, তাহলে কি পরিমাণ তারা টাকা মানে অর্থ তুলে নিচ্ছে চিন্তা করতে পারো? বুঝতে পেরেছো?
Yes, sir.
সো এসব ক্যাসিনো মেসিনো খেলবা না। For 11 homework, I'm going to do 12. Suppose that a school has 20 classes, 16 with 25 students in each, 3 with 100 students each, and 1 with 300 students each, for a total 1000 students. What is the average class size? মানে ক্লাসে average কতজন স্টুডেন্ট আছে? If a student randomly out of 1000 students, select a student randomly out of 1000 students, let a random variable x equal to the size of the class. তার টার্গেট কি আমাদের? ক্লাসের সাইজ কি টার্গেট? For the class size we have to define the PMF and then find the expected value. So let's go. Mm. 12. The average actually mu. They have 16 classes with 25 students. They have 3 classes with 100 students. They have 1 class with 300 students, and they have in total how many classes? So average classes is what? What is the average class size? 50. What is the average class size?
50.
50. Now it was A. Now B. Actually, class size is the target. The class size are 25, 100, and 300 respectively. So what is the probability of the class size 25? That is, what is the probability of x equal to 25? In total, 16 classes with 25 students, divided by total students 1000. So it is 4 by 10. So probability of getting classes with 25 students is 4 by 10. That is total student in this class divided by total student in this school. Similarly, 100. 3 classes with 100 students divided by 1000 students. 3 by 10. And finally, probability of x equal to 300. So 1 class with 300 students divided by total. So 3 by 100. Sorry, 3 by 10. Now see the expected value. Here 25 have the probability 4 by 10. 100 have the probability 3 by 10. And 300 have the probability 3 by 10. So it is 130. Do you understand?
Yes, sir.
Next
So,
chapter is about mechanical clear, sir. Because I'm not specific.
oh, we'll start the next chapter because already in the last class I have started the next chapter for the another section. So I have to start for equality, but will not complete the chapter. Okay. Next chapter is very similar to this. The application of this chapter, just nothing else. Special mathematical expectation. Actually, this special means these are application of the mathematical expectation. That is, in which field or why we should use the mathematical expectations. Do you understand? The first page is a review of the last class, previous chapters. So we are not intend to read the first page. I want to start from here. The variance and standard deviation. The variance and standard deviation is application of, in the last chapter we have seen the mean, right? Average. And in this chapter we will study the variance. So the variance is one kind of what? Application of mathematical expectation. Application of
Mathematical
Exception.
how the variance. Say you have already found the mathematical expectation and we call it mu. We know this. This is the average value. We want to know what is the average fluctuation. That is একটা ভ্যালু থেকে সেন্ট্রাল ভ্যালু থেকে মিউ থেকে অন্যান্য ভ্যালুগুলো কেমন দূরত্বে অবস্থান করছে এটা আমরা বের করতে চাই. This is called variance. It can be found by expectation of x minus expectation of x minus expectation of x whole square. This is the sum of x minus mu whole square fx. So we can find the average fluctuation. Then it's called sigma square. Its square root, positive square root, is called the standard deviation. This is called the variance, denoted by sigma square, and its square root, positive square root, is called the standard deviation. Like in the last math, in the last chapter, we have found the mathematical expectation was 10 by 6. The inputs were $1, $2, $3. So 1 minus 10 by 6, that is 1 minus the average whole square into its probability, 2 minus the average whole square into its probability, 3 minus the average whole square into its probability. So what is the variance here? 5 by 9. 5 by 9. So The standard deviation is the square root, positive square root. This is 0.745. This is the average fluctuation. Variance not average fluctuation. This is the square of the average fluctuation. So standard deviation is the average fluctuation. So average fluctuation or average deviation হচ্ছে কত? তাহলে ইনকাম কতটুকু ভ্যারি করতে পারে? $0.745 কতটুকু ভ্যারি করতে পারে?
0.745.
কেউ কম পাইতে পারে, কেউ বেশি পাইতে পারে, কিন্তু এর বাইরে যাবে না। সেন্টার ভ্যালু থেকে 5/3 থেকে এতটুকু কম বেশি হইতে পারে। কিন্তু এই ক্যালকুলেশনটা একটু জটিল, তো আমরা এই ক্যালকুলেশনটা এইভাবে করবো না, কারণ এখানে আমাকে আগেই এভারেজ ক্যালকুলেট করতে হবে, দেন এখানে বসাইতে হবে, এটা অনেক ঝামেলা। Instead, we'll solve this. আমরা এইভাবেই করবো। That is, I will solve sigma square is expectation of x square minus expectation of x whole square. That is, I will find these two quantities first and then input here. এটা আমার জন্য বেটার না? কি বলো?
Yes, sir.
Like here. এটা কিন্তু আমি মিউ স্কয়ার লিখছি, মিউ কিন্তু এক্সপেকটেশন অফ এক্স। সো এইভাবে লিখলে এটাকে আমরা আলাদা করে জাস্ট এক্স স্কয়ারের জন্য ফাইন্ড আউট করেছি, আগেরটা বসিয়ে দিয়েছি, একই রেজাল্ট আসছে, এটা বেটার। আশা করি বুঝতে পারছো। এখানে এক্সাম্পল 1টা আমি করবো না, বিকজ আমি যখন 3 করবো এক্সাম্পল 1টা অটোমেটিক্যালি চলে আসবে। সো আমি 2 করছি, 2 করে আমি ওকে সামটাইমস এক্সপেকটেশন আর 0, দেন যদি এক্সপ্রেশন 0 হয়েই যায়, তো আমার এটা ক্যালকুলেট করার দরকার আছে বলো তো? এক্সপ্রেশন যদি আমার এটা যদি 0 হয়ে যায়, এটা আমার বসানোর দরকার আছে বলো? 0 হয়ে গেলে
No, sir.
তখন ভেরিয়েন্স ইকুয়াল অনলি কি হবে? এটা না? That is the example 2. They have said this is actually example from the previous chapter. We got the expectation is 0. Since this is 0, we can get only the expectation of x square. Then we get the desired variance. দেখতে পেয়েছো? 0 হলে আমাদের অনেক সুবিধা না?
Yes, sir.
Now you want to find the general form of the mean and variance of the uniform distribution. Let us choose a uniform distribution have m positive integers, that is 1 to m. Like for a head, for a coin, this is head and tail, that is 2 outcomes, m is 2. Say in a dice is 6, so m is 6. For a card is 52, m is 52. Okay, this is general. It's what?
No, sir.
General. Now, f the mean, that is expectation, is x fx. Fx is 1 by m. M is constant. So constant বাইরে চলে যাবে, আমরা বলে আসছি, তাই না?
Yes,
Then
sir.
sum of x, that is sum of 1 plus 2 plus 3 up to m. So m number of positive integers have the sum. Positive integers have the sum, or natural numbers have the sum m into m plus 1 by 2. Then m cancel. You can write m plus 1 by 2. Then expression of x square. Here we can write 1 by m, 1 second constant x square. Some of the m natural numbers, first m natural numbers have the sum m into m plus 1 into twice m plus 1 by 6. Once again m cancel. This is the. Then the variance, we can find the expectation of x square and expectation of x whole square. Just after calculation we get this. Now I want to going back to the example 1. If I put m equal to 6, I will get mu equal to, if I put here example 6, m equal to 6, what can we find? 7 by 2?
Yes, sir.
Also the variance m square minus 1. So 6 square minus 1 by 12. So it should be 35 by 12, right? Okay.
Yes,
You can
sir.
see which is exactly given here. Can you see? Right?
Yes, sir.
So you can remember, if you can remember the main formula, you can use it directly. আমার কোনো বাধা নাই, বুঝতে পেরেছো?
Yes, sir.
Now the formula, if y equal to x plus b, then expectation of y is equal to what we can write here. The expectation of y is equal to the expectation of ax plus b, which is a expectation of x plus b. Can I write it? Use the linearity property. Okay. That is a. This is actually mu of x. This is what? Mu x plus.
Mu of x.
Then, if you want to find the variance of y, this is variance of y, sigma square y. This is expectation of y minus mu y whole square. This is actually mu y. Then we can write y equal to x plus b and mu y equal to a mu x minus b. You can see mu cancel, right? Sorry, b cancel. A is constant. If I take a is a common factor outside of the square, a square, x minus x bar, sorry, mu x whole square, then we can write this. That is, the final thing is, if you want to find the variance, sometimes you write this as v. Variance কি দিয়ে লেখা যায় বলো তো? V. V of x plus b is equal to, b will be cancelled, a square vx. Do you understand? A square v of x. Okay. Hello.
Yes, sir.
Now you want to find moments. What is moment? Moment actually basic কোন definition নাই expectation মতো, but এটা তোমার একটা যে আমরা অলরেডি দেখে আসছো যে কি করি, লাইন গ্রাফগুলো ড্র করি না, সেই লাইন গ্রাফগুলো জয়েন করলে একটা গ্রাফ পাওয়া যায় না? মনে আছে আমরা লাইন গ্রাফ ড্র করি যে?
Yes, sir.
If we join them, we'll get a curve. This curve is called a distribution curve. This curve is called
Distribution graph.
and the shape of the distribution curves are defined by the moment. তাহলে মোমেন্টটা হচ্ছে যেটা আমার ডিস্ট্রিবিউশন কার্ভের আকৃতিটা কেমন হবে এটা ডিফাইন করে। ক্লিয়ার?
Yes, sir.
Usually a moment from the b, around the b is any point, in our given subset. The moment, earth moment, the power r, this is earth raw moment from around b is defined by expectation of x minus b to the power r. So x minus b to the power r fx. This is earth raw moment about what? B, where b in the subset of the sample space Sx. B in the subset of the, sorry, B lies in the subset of Sx. Clear? Sometimes B may be 0. That is mul bindu, তাই না? Origin. B 0, that is what? Origin. Then this can be written by this. But don't try to memorize this. Try to memorize this. This one, the general form. Here usually we used to apply r equal to 1, 2, 3, 4. So to define the shape of the distribution curve, we need only how many moments? 4 moments. Then if b equal to the expectation of x, this is called central moment, is equal to mu. This is called what? Previous one was raw moment, but this is central moment. That is, the central moment is defined by expectation of x minus mu whole to the power r. Do you understand? This is a central moment and defined by sum of x minus mu whole to the power r fx. Do you understand? Okay. This is earth central moment. This is what?
Art
Art
center and
central moment.
Central moment.
If r equal to 2, then it will be variance. তুমি বসায় দেখো, এখানে r equal to 2 বসালে x minus p whole square fx, এটা কি ভ্যারিয়েন্স না? So second central moment is the variance. Please note down this. Okay. Second central moment is what? Variance. E. বুঝতে পেরেছো?
Variance.
নোট রাখবে কিন্তু এগুলো কিন্তু লেখা নাই, আমি তোমাদের লিখে দিচ্ছি। আমাদের 4 দরকার নাই because it was theory. Then moment generating function. Sometimes the distribution cannot be derived directly using the usual expectation. Then we need to find the moment generating function. This moment generating function used as t, basically t for time, but sometimes it may change. The moment generating function actually expectation of e to the power tx, which is sum of e to the power tx fx. Do you understand? One funny fact, if you have the fx, that is the PMF, you can find the moment generating function mgf. Also, if you have mgf, going back, you can find PMF. তাহলে PMF থেকে mgf এবং mgf থেকে PMF দুটো কি করা যায়? ক্যালকুলেট করা যায়। কি করা যায়?
calculate করা যায়।
Okay. If x equal to 1, then fx give the probability of 1. If x equal to 2, fx give the probability of 2, and so on. I'll show this now. You can see this is a moment generated function because I can write it. How can I write it? I can write a sum of e to the power tx fx. Can I write it? You can see the coefficient of t is 1, so this is the probability of 1, isn't it? Here the coefficient of t is 2, so this is the probability of what? 2. This is the coefficient of t is 3, so this is the probability of what? 3. Probability of, hello?
Yes, sir.
Can you see? Easily from the moment generated function we can find the probabilities, and then using the probabilities they are decreasing gradually, and using chapter 2.1 and those probabilities we can get this. This is PMF. That is from moment generated function we can find the probabilities, and using the probabilities we can find the PMF. Do you understand?
Yes, sir.
We'll discuss this more in the next class. Okay, I'll stop this class here because I cannot bear more. This is the last math for today. The moment generated function. Oh, one thing I want to show. But moment always m0 equal to m0 must be 1. M0 must be 1. Why?
1.
M0 is equal to actually expectation of e to the power tx, so 0. 0x. Okay, so e to the power 0 is expectation of 1, and expectation of 1 is what? 1. Am I right?
1.
Also, we can write here the moment generated function m0 is equal to, in another sense, e to the power 0 fx dx. Fx. So e to the power 0 is 1 fx. What is the total of f? 1. Am I right?
Yes, sir.
So in both way we can show the total probability is 1. If you cannot show total probability is 1, then you are wrong. Sorry, moment m0 equal to 1, you are wrong. Look at this. Here mt is e to the power t by 2, 1 minus e to the power t by 2. We have to first check whether m0 equal to 1 or not. If we put 0, e to the power 0 is 1, so half divided by 1 minus half, and you can see half by half. Am I right? This is what?
Yes, sir.
1. Then we can go through because our calculation is correct. Then this can be written in this form. Can you write it? That is 1 minus e to the power t by 2 can be written in inverse form. Can you write it?
Yes, sir.
Okay. Now we know the infinite binomial theorem, অসীম দ্বিপদী উপপাদ্য, এভাবে লেখা যায় না? যায় কিনা? আচ্ছা আচ্ছা, ইন্টারমিডিয়েট থেকে লিখছি, ঠিক আছে। এটা হচ্ছে অসীম দ্বিপদী উপপাদ্য, এটা কিভাবে লেখা যায়? Then just take z equal to e to the t by 2. We are taking z equal to what? E to the t by 2. So e to the t by 2 is outside of this 1 plus z, that is 1 by e to the t by 2 plus e to the 2t by 2 square, like z square, then e to the 3t by 3t square. Do you understand this line?
Yes, sir.
Hello. Okay. Now multiply e to the t by 2 to the all of the parts. You can write this. You can write this. E to the t by 2, e to the t taking out half to the power 1, then e to the 2t my multiplied half a square. So I think I can write this e to the power xt half to the power x. Can I write it? Can I write it? Hello. So this is the PMF. Do you understand?
Because summation factor এটা বুঝলাম না, e to the power x to the half.
কোনটা? কোনটা?
Summation of e to the power x.
Oh, okay, just wait. If you put x equal to say 1 to infinity, okay, put x equal to 1, you will get the first term. Please check. Can you get it? If you put 2, we get second term. Can you get it? It was 2t half
Okay,
whole
sir.
square. So we can definitely write this summation form. Okay. So we compare this with the form e to the xt fx. So fx is this. Do you understand?
Yes.
Okay. I cannot continue anymore, please. I am going to stop. Any question?
No, sir.
If you have any question, I will give you an answer in the next class, if possible. কালকের মধ্যে শরীর ভালো না হলে আমি ছুটি নিব, হয়তো রাতে জানাবো। যদি কোনো মেইল না পাও তাহলে ক্লাস হবে, আর মেইল পাইলে তো হইছে।
স্যার আপনার শরীরের অবস্থা কি স্যার?
জ্বর আছে, গলা ব্যথা আছে। যাই হোক, আমি অ্যাটেন্ডেন্সটা নেই, তারপর কথা বলি।
মনে করো ভালো।